Cities. Uh, it is December 2020, and my, what a year it has been. Joined with me today is Daniel Craig. So you've probably seen him from some of the previous meetups. And then I'm John Jelinek. And so we want to wrap up this year. It's going to be a little bit of a different flow than some of the previous meetups. We don't have a single speaker for the whole thing. This is going to be more of a collaborative, somewhat more hands-on type of session, just for some fun activities and ways that we can just wrap up the year. So if you're watching live, welcome, and if you catch us on the stream later, hopefully you find some interesting parts that you can jump to in the video. So let's move forward a little bit. So what is Clojure Mid-Cities all about? This meetup exists to help people explore the functional programming paradigm with Clojure so they can build simpler systems. So instead of the object-oriented paradigm with all this inheritance and whatnot, I've found personally that functional programming tends to help me develop simpler solutions, and it seems that I'm not the only one that's true of. So this meetup exists to explore that further, so that way more of you can have that aha moment. So an agenda for tonight. One is we're going to do a walkthrough on setting up Clojure on a Chromebook. I just recently got the Flex 5 from Lenovo. It is a Chromebook, and so you're going to watch me set up my dev environment running Clojure on this Chromebook. After that, we're going to switch over to Daniel Craig, where he's going to talk about a really interesting project that he's been working on, and he'll demo that. After that, we will pick up another Project Euler problem. The second one, I think it's a Fibonacci problem. So if you're in the chat, hopefully you'll be able to join us as we work on that. And then finally, I want to review a resource that I just recently became aware of called Today in Clojure. It's kind of like a Clojure Hacker News. And so that's a really interesting resource. And so I want to talk about some of the items that just came across there recently. So let's go ahead and get into it. Setting up Clojure on a Chromebook. I'm going to switch over my screen so that way we can work on this together. Just a moment. All right, so you might be wondering, okay, well, why do any type of Clojure on a Chromebook? Well, my pragmatic solution is, see, I have a iMac right over there in the corner, and it just recently died over the holiday. For whatever reason, the monitor started going black on me, and I've not yet been able to log in for a bit. And so at my disposal was this little Chromebook that I purchased that I mentioned recently. And so just in time for this meetup, I wanted to know, can this run Clojure? Can I do something in here? Am I able to run at least some familiar tooling? And to my surprise, I was able to. And so I want to show you how to install Clojure on a Chromebook, one of the Intel-based ones, if you've got one available, right? So if you have one of those Chromebooks, one of the things that you can do is you can turn on Linux mode, right? And so it is a beta feature. And so if you do that, which we won't cover that here, but it comes with the terminal. Well, with the terminal, I can do all the things that I was expecting. It is a Debian-based Linux distribution that you get access to here. I'm actually not sure what it gives you, but let's see. Is there? Oh, you know what? I bet I can. Uname R. Well, that's just tell me the kernel that it's running. Anyway, but you do get access to apt, right? So you can do apt get updates and apt get upgrade. But the thing that you're interested in is running Clojure. Well, there's a couple things for that. One is you're going to need Java. And then another thing that you're going to need is Clojure itself. And I don't have to necessarily install these in any particular order, but I'll need both of those to make this work. So if I want to just go ahead and get started, I'm going to go over to clojure.org and click on Get Started. I can follow the exact same instructions that I would do for any other Linux distribution. So, so here's the installation script for Linux. I'm going to go and just copy this script. Okay, we'll just paste that in. And then I need to change mod it. So we'll do that. And then I'm going to run it. Okay, so now I've got in my user local bin, I've got a Clojure and a CLJ command, right? So CLJ just is the Clojure command, but with RL wrap, which gives you some niceties at the terminal to make the experience a little bit better. So, right, if I run it right now, it's going to say, oh, I need to find Java. Well, there is this nice package manager for Linux distributions called ASDF, right? And so I happen to have that one on hand. If you're not familiar with it, yeah, it's got a collection of different tooling and programming languages that you can just install very easily, no matter which distro you're running. So if I do ASDF plugin plugin add Java, it's going to add the plugin for installing Java. And then if I do ASDF, let's see, Java list all Java. Let's see, Java, right? I can see all the different Java distributions that I can install, right? So for this demo, what I'm going to do is I'm going to install one of the Corretto, which is a distribution of OpenJDK that, or yeah, I mean it's a OpenJDK fork, but that is supported by AWS. So if I do ASDF install Java and then paste in what distro I want, then it will go ahead and install that. Okay, and then in order to set up that Java home, I'm going to actually modify my .bash rc, right? And then down here, this is all I need to add, right? There's this little script right here that will set that up for me, right? Yes, I
Can you
can.
hear me, John? I just wanted to comment. If you've ever installed Oracle JDK on Linux, this is making Oracle JDK on Linux look like an absolute bear
Oh
to
yeah.
install. That was the easiest thing compared to
Oh
Oracle that
yeah.
I've ever seen.
Right. Absolutely. Yeah. Okay, so now that I've installed a version, well, so with ASDF, I can actually install multiple versions of the Java runtime or JDK, Java Development Kit. And so if I want to set what my global Java, like my default one is, if I'm not in a particular project, I can run this command ASDF global Java and then put in the one that I'm interested in, right? And now, right, I can run which Java is going to say, oh, there's a Java. Well, I want to know which one I've got. So ASDF which Java. It's going to say, oh, you're running Corretto 11. And so if I do like Java version, right? So now that's all accessible. So if I go back to my Clojure command, then it will detect, oh, now I've got my Java home set up, and it's going to do all the things necessary to set up Clojure, right? So, so now I've got a working Clojure environment on my Chromebook. Well, I can take it to the next step with Visual Studio Code. So if you are not very familiar with that, I mean, you can follow the exact same processes that you would for another Debian-based installation if you're running an Intel-based Chromebook. Let's see. Let's go to code.visualstudio.com. Here we go. Download. Right? You'll want to get the Debian package. Right? That'll install. So after that, you can just do apt install and then pass in the deb file that you just downloaded. One thing to note, if you're on a Chromebook, you will need to drag the file from your downloads into your Linux distro. So I'll just show you real quick how we do that. Okay, so this is done. I can do show in folder, and then I'm just gonna take this file and we're just gonna drag it over to Linux files. And it's going to copy it over, right? That's it. All right. See, so now we've got that deb file. I can do sudo apt install code. There. Right? It says I've already got it. So I did that a little bit ahead of time. All right. So now I don't need to do anything else in this terminal. What I'm going to do is I'm going to open up the everything button and then type in code. There we go. Right, and so this is going to open and I can install the extensions that I'm used to. So I grabbed me an Emacs extension and I got me the Calva extension, right? So so over here I got Calva, which came with CLJ Condo, and then also I got the Emacs friendly key map as well. So here in my terminal, inside of VS Code, right? So I'm in one of my just scratch directories. I created a deps.eden file already that's pretty empty, and a source directory and a scratch.clj. If you have this deps.eden, then if you run Calva, it's going to know that, oh, this is a closure project, and I can pull in any dependencies that were picked up from that. So if I go down here to the in REPL, I can start a REPL, and that's going to say like jack in, just kind of like your other in REPL plugins may also say, if you're used to using Emacs, for example. Okay, so it's going to launch a REPL, and so the Chromebook's not necessarily the fastest thing around. Okay, here we go. So we are so hooking up in REPL sessions. It's got the port set, and so in REPL trying to connect. Okay, and we're in. So jack in, done. Okay, so now, just like I would in any in REPL environment, I can type in some code and I can start to get some quick feedback. So for example, I can do Command-Shift-P, type eval, right? And it'll say Calva evaluate current form, right? So I can do that. And then over here, also the hotkey is Control-Enter, right? So I can do that and get my immediate feedback over here, as well as over in the Calva REPL output as well. So so that's it. Closure running on a Chromebook. Not the fastest thing in the world, but you know what? This Flex 5 Chromebook is running an i3. So if you're on, for example, the Pixel or the Pixel Book, you're gonna have a drastically different experience. But I look forward to exploring running more things on this, because it's a little bit more mobile than this iMac that that died on me. So with that, I'm going to pass it over to Daniel, unless anyone's got any questions.
I've got an iMac on my desk now, and now I'm concerned.
Yeah, right. Well, this one back here is from 2010, so it's
okay. So mine's a little newer.
Yeah,
mine's
right.
A little bit newer than that. So
A little bit, yeah.
Yeah.
Awesome.
Well, that was really cool to see.
Yeah, absolutely. Well, if you want to share your screen, then
sure.
Yeah, you can show us the project you've been working on.
I'll do that. Let me make sure though that I'm not sharing. Oh, last time when I shared my screen, did it share both screens? I think it
No.
did.
Well, so you get to select when you click the share screen button.
Okay. Entire screen. Okay, this is what I'll do. So I'm going to consolidate my Firefoxes, and I'm going to say entire screen. And I'm only, oh, well, it is showing my entire. Okay, that does it. I'm just going to use my laptop screen. Turn off the other. Okay, let me just take one quick second and reshare it. Entire screen. So to give a quick introduction to my topic that I wanted to talk about, recently I've been learning about T++. So this came about because I attended a conference that Proctor talked about on his podcast, which is called Code Mesh. And Leslie Lamport was there, who's a very famous concurrency researcher who's at Microsoft. And he won the Turing Award, and he's very impressive and intimidating. So I was a volunteer at the conference, so they asked me to write questions for all the speakers. So I wrote questions, but I wasn't expecting to be so impressed by Leslie Lamport. And when I wrote my question, it wasn't anything that even addressed like the level that he was prepared to speak at. He talked about math. He talked about thinking about code above the code level. He talked about like modeling your systems as mathematical systems. Oh, I'm still talking to myself, aren't I? When I shared my screen, I forgot that you would see myself in my screen share. So, okay, so yeah, he talked about modeling systems as mathematical systems, and it was really exciting to hear the way that he thought about concurrent processes and stuff. So just to give you a quick description from the webpage, he says TLA Plus is a high-level language for modeling programs and systems, especially concurrent and distributed ones. It's based on the idea that the best way to describe things precisely is with simple mathematics. So that's kind of baked into the foundation of what TLA Plus looks like. So to give you a view of what that looks like, this is a TLA Plus specification for a somewhat well-known puzzle that talks about missionaries and cannibals. So imagine yourself in the scenario where you have to ferry a group of missionaries and cannibals across the river. Missionaries can never be outnumbered by cannibals, or they'll be eaten. They can only cross the river in a canoe that cannot cross the river by itself. Only one or two people at a time can fit in the canoe, no more. And like I said, cannibals can never outnumber missionaries. So Leslie Lamport's TLA Plus tool addresses not only complicated big systems and protocols and things like that, but also puzzles. So as an introductory learning experiment, I dove into learning what TLA Plus looks like through reading this. So it starts out fairly straightforward. It just says that it's going to be using integers and sets, and those are both mathematical ideas. It talks about missionaries and cannibals. And it talks about having these variables, bank of boat and who is on bank.
Hey, Daniel.
And,
Can you make the text a little bit bigger?
Oh, totally.
Awesome.
I always overlook doing that, and I need to make that a habit. Let's make sure that this is legible. So what it does is it models. Maybe this is. Here's what I'll do. I'll pull it up in GitHub because I'm not sure how in the toolbox I'm able to do that. So let's pull it up in GitHub. So these are different definitions, including a definition of type OK, which basically is sort of a predicate that says that nothing is in a bad state. So your program state was, in this case, defined as being composed of two variables, the bank of boat and who's on the bank. So in TLA plus, everything's mathematical, as we said. So your sets are sort of your primitive here, and then you've got this operation called in, and then this is an and. So this is a conjunction of two conditional things. Bank of boat is in the set east or west. Who's on bank is in the set of functions that maps the set east and west to the power set of Cannibal's union with the power with the set of missionaries. So it gets to be a little bit complex, but this is kind of idiomatic TLA plus that I'm learning is not as unapproachable as it seems on first blush. But to take it one step further and make it a little bit more understandable, you can make every TLA plus spec into a PDF. So if you take that route, then you'll see that it goes a little bit further into human approachability region, and then converts the symbols into more readable mathematical symbols. So with some training, this becomes pretty legible. So like I said, this is the N, this little symbol that looks like an E. So you expect that the bank of boat is going to be in the set east or west. And you expect who's on bank to be mapping from the set east and west to a valid set of cannibals and missionaries. So in TLA plus, program execution is modeled as state transitions. So essentially, you're not writing a program in TLA plus, you're writing a definition of what a valid set of state transitions looks like. And then you've sort of got this implicit model that is composed of all the expansions of all the possible state transitions that the state could undergo. And you just sort of make the assumption that that's a bounded thing, and then it walks all the states that you could possibly arrive at, and then your program execution, regardless of whether a user would actually ever put that in or whatever. It thinks way above that level. It's just purely about the model and the state. So the next part of this spec is about definitions of what you can do in the program. So the first thing that you want to do is you want to define what it means to be safe. So the cannibals can never outnumber the missionaries, right? So essentially, and this is where you may start to see like a similarity with Clojure here, or with Lisp in general. You'll say, okay, so we're going to define what it means for it to be safe. It can either be that there's only cannibals on the bank, or that the number of cannibals is strictly less than or equal to the number of missionaries. So we've got this these ors. This is the symbol for or. If you think about formal math, this formal symbol for or means that either S, which is the set of people on the bank, is a subset of the set of cannibals, or the number of people on the bank that are cannibals. That's the intersection sign. So the intersection of the people on the bank with the set of cannibals is less than the number of people on the bank who are missionaries. So like I say, like this is all kind of foreign stuff until you kind of get that grasp on the mathematical symbols, and then it all becomes very expressive. So the reason I said that it's like you'll see some similarity to Clojure is because I find that in Clojure and in Lisp in general, you have these like really broad-reaching functions that somehow distill everything into a few simple lines, and it's usually like an or something. And you'll just sort of look at it and say, is that really all it took to define what it meant for, in this case, a side of the river to be safe? Either it was just cannibals or the cannibals were fewer than the missionaries. Like, I never thought it could be so simple. And yet, when you just define it, that's all it requires. So that was the first thing that kind of made me say, wow, okay, there's something to this. So now here's a definition of the other bank. So if you provide east, then it gives you west. Otherwise, it gives you east. It's kind of a one-liner that's just sort of for the utility of being able to say, what's the other bank if I know what this bank is. So now there's a definition of move. So the and says that both of these things have to be true. Both the cardinality of S, the set of people that you want to move, has to be either 1 or 2. It has to be in the set of 1 and 2. And then this is where another similarity closure, and the first one that really made me say, I want to implement this because it's so similar. And you have this block that has to be true, and it lets you bind these names first to the results of these functions. And it even uses the same name, let. So this is essentially a let binding. You're saying new this bank is the future state of this bank minus, well, essentially it's the future state of this bank defined as who's on the bank right now minus the people who are leaving in the boat. And then the other bank is defined to be the people who are on the other bank unioned with the people who are on the boat. So essentially you're taking those people that are on the boat and you're moving them to the other side, but you're not doing it in a mutating way. You're doing it in a way that defines what the next state is. And then the in definition defines that all these conditions have to be true. The is safe new this bank says this bank has to be safe. The is safe new other bank says that the other bank has to be safe after this change is made. And then bank of boat prime, that's sort of like saying the next state of the bank of boat, which that's a convention that's common in TLA plus. It has to be equal to the other bank. So essentially the boat can't leave and come back to the same bank. And who's on the bank has to be, essentially it has to be a mapping of the set east and west to the new this bank and the new other bank. So you have to be able to make a correlation between east and west and the new this bank and the new other bank. So maybe I've dove too far into it already, but I just find that it's really interesting to know all this stuff because it kind of really reminds me of the foundations that Clojure and Lisp have in math. So my first takeaway, one point that I've already made, is just that it's striking that Clojure shares so much with a language that's just so mathematical. And the value add that TLA Plus offers is that, if you've tested your program with TLA Plus, it's essentially proven to be correct. You can be confident that in every possible execution of this program, you never got into a state that violated the rules that you defined. Kind of like spec, but in a more formal sense. It doesn't just tell you if it violates it. It actually lets you prove that it's correct by walking every possible state. So I think I'll go on now because the next thing that I want to show you is how I implemented it. So I actually took to go back to the plain text version, I took these definitions and put them as comments in my Clojure code. So you'll see that. To give a few introductory comments, I implemented this as a reframe application. So if you've watched me present on this meetup before, you know that when I first presented, I just barely learned the fundamentals of reframe, and now it's really starting to pay off. It was really fun to do this project. So I can't recommend it enough. I think Gene Kim also recommended it when he talked at the start of the year. So yeah, seriously, it was so fun. So this is my namespace, boatcrossing.views. I've just done it all in the views. I didn't part it out into some import or anything like that. So I'll just go ahead and jack in, and then I'll walk you through what it does. But you're essentially going to see the same parts come to play that I explained from the spec. So typo K does this comparison. It says the bank of boat has to be in the set of east or west. The bank of boat is defined in my implementation to be a keyword. So if this keyword's found in this set, then that's true. And if who's on the bank is a subset of everyone, then this is all okay. So you're in a good state. So is safe, other bank. Those definitions match the ones that I described. And John, how's the font size? Is it okay?
If you could do just a little bit bigger, that'd be good.
Cool. So this is the one that I struggled with. It's probably the one where my closure code shows the most that I'm a newbie, because I have a nested let if, but essentially, like, this is the one that says move. So if, oh gosh. Okay, so if who's on the boat is either one or two people, then you're going to be proceeding to check that both sides of the bank after the transition are going to be safe. And if that's the case, then you're going to make the boat move. And then I added this functionality to have a concept of who's in the boat. That's not really part of the model, but you know, like I said, TLA Plus thinks above the implementation level. So sometimes you have to make a few additions to make it all practicable. So I'll just give a quick demo of how it works. So one thing that I love is just how easy it is to make things clickable in Reframe. I know it's probably simple to somebody who's done a lot of web development, but as a person who hasn't, it's just really a thrill. So what I did was I just added these two to the boat, the second missionary and the third cannibal, and I said, okay, I'm going to send them across to the West Bank. So you can see that was safe. I didn't leave missionaries outnumbered, and I didn't have an invalid number of people in the boat. If I had, the rules would have caught it. I can be confident of that because TLA Plus proved the spec. And so I'll just make my next move. So what I want to do is demonstrate these rules that I put in, or these alerts that I put in. The boat can't move, of course, if it's not safe or if it doesn't have a valid number of people on board. So you'll see that I've let it know how to tell the audience, the user, this message, that it must have a valid number of people on board. And it also has the ability to tell you if it's not safe to send someone across because of the situation that it would create. So in this case, and this is actually where my mind first just sort of was blown by how cool this was. I didn't have to think about the logic of this. I didn't have to like say, oh, is there some edge case like that I haven't thought of? Like, oh, I'm just not sure if it's correct. Like, I just implemented it from the TLA Plus, which I should say I didn't write the TLA Plus spec. This was one that's given us an example. But I didn't have to doubt it because it was proven. And when I went to try it, I couldn't send a cannibal across because when he arrived, it would create a situation where he outnumbered missionaries. So just the fact that I didn't even have to think about that, like the edge case was basically provided for, just totally blew my mind. It was incredible. So I feel like as a result, I just want to learn more TLA Plus, and I want to get really confident with it to the point that, you know, if there is a system that's truly critical, like if you have some system where you have to guarantee that, like, something can't happen twice, or, you know, something has to fail over and then the original one can't come back and start sending like contradicting signals or something like that, some sort of deep systems problem, that's the stuff that I'd love to be able to say, like, yeah, I'd love to attack that. I've always wanted to be the type of person that could solve the deepest problem. So, anyways, I feel like this is one tool that's really helped me to tackle something that I thought would have been too academic for me. And it was really a thrill. So I just recommend TLA Plus to anyone that's interested. And it essentially was made a lot easier than it would have been otherwise, because Leslie Lamport has a whole lot of resources online, including a video course that's free on YouTube. So I'll just show you how to get to that first. So you just click on this guy. If you've arrived at his website, which you can get to by just typing in TLA homepage into Google, then he's got this video course here, and it's just really cool. So I guess that's the only criteria it has to pass for it to be worthy of talking about, but I really enjoyed it. So
Like,
I think that's everything I have to present, John.
Awesome. Yeah. How did you learn about it?
Well, just that conference, because honestly, like, I wouldn't have ever thought that I needed to learn something like this, because it's the sort of thing that people say is for formal proofs, and you wouldn't need to use it unless you're doing something safety critical, like a nuclear reactor or avionics or something like that. But I found it to be interesting well outside of anything safety critical.
Yeah, that's really cool. What might be interesting is to see this implemented with closure spec, to see how that impacts your reframe.
That would be sweet. So actually, I've never used spec yet. It's still on my short list of things to learn. So right now, I'm actually learning core async.
Okay.
So maybe next will be spec.
Yeah.
I
Yeah.
just bought Timothy Baldridge, I think is his name. He has a video that he made for O'Reilly about core async, and I bought a DVD of it. They had on, well, actually, I got it as a birthday present, but they had it on eBay, and I thought, well, I don't want to subscribe to Riley. I'll just get the DVD, and so now I'm working through it, and it's pretty exciting.
That's great. Yeah. Yeah. I think core async is great, right? Like just as a quick aside, the way that they could implement those features using just a library instead of a language feature, right? That really shows that power, and that even I remember it being around, I think even before promises in JavaScript were released, and so, or perhaps right around that time or whatnot. And so to have that implemented before the language, made it a first class, um, you know, kind of thing, right? It was just really cool.
Yeah, I'm really, every time I like grasp something new in it, and it's been slow going because it's not easy to find time to sit down and watch training and stuff like that. But
Yeah.
every time I grasp something new in it, it's just like, oh my word, like like this is the sort of stuff that if I was to never leave the Java world, I'd probably think was purely the realm of academic researchers and stuff. Like I'd never touch this stuff, but if you think about it, like it's all applicable if you have an imagination to think about, like, well, what types of problems could I solve with this? And then you start to think about all the possibilities and in my case, you start to think about like, oh, like what side project could I make with this? Like what could I found? And,
Yeah.
could I have some sort of passive income that could come from this? But it,
Yeah.
everything takes time. So it's
Yeah.
just a learning thing for me,
Yeah.
for right now, at least.
Yeah, I mean, what might be fun in a future meetup might be to create a stock trading app, a little bot, using some of these proofs, right? Some of these specs that can help you make those decisions, right?
Yeah, that would be cool.
Yeah.
Okay.
All
Well,
right.
I'll stop my screen share.
Yeah. Well, I mean, you can probably keep the screen share because next let's pull open a Project Euler problem and see if we can work it and see if we can come up
Sure.
with the right solution. So, so just like previously, we went to projecteuler.net. So projecteuler.net, and then hit the archives, and we'll take a look at problem number 2.
Oops, that's not the right one.
Yeah, there we go.
Okay.
All right, so I'll let you read it out loud, and then we could talk about what you would like to do to tackle this problem.
Sure. So it says each new term in the Fibonacci sequence is generated by adding the previous two terms. By starting with 1 and 2, the first 10 terms will be 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. By considering the terms in the Fibonacci sequence whose values do not exceed 4 million, find and sum the even-valued terms. Find the sum of the even-valued terms. Okay. So this is a little different than I've done before because I've done recursive Fibonacci and closure once.
Okay.
But it was before I knew how to use loop recur. It was just a true recursive. So tell me, John, last time you told me you had a preferred way of starting the REPL in the terminal, didn't you?
Oh yeah, sure. Right. So do you remember Rebel readline?
I know a little about it, but I don't remember exactly.
Yeah. So if you just pop into Google Rebel readline, I don't know if you added it to your system's deps.eden file. But if you didn't create it as an alias, you can initialize it with the command that's about to show up here, right there. Yeah.
This one.
Mm-hmm.
Okay.
Yeah, and then try to make that text a little bit bigger.
Sure. That should just be a reflex for me, I guess.
Yeah, I think last time you were able to just Control plus a few times.
Oh, that's right. Yes. What was it that I
Or
did?
maybe it was, like a mouse wheel or something. There you go.
That's doing it. Oh, great. How does that look?
Yeah,
That big
that's
enough?
great. Yeah.
Okay, good.
Absolutely.
Okay, so I want to do a Fibonacci program. So Fibonacci is a recursive sequence.
Mm-hmm.
So what I know how to do is this. So essentially with Fibonacci, because you have in any given iteration, you have 3 numbers. If you call them A, B, and C, then it's almost like you can think of the second 2 as becoming the first 2 in the next iteration. So like the sum of the, call them A, B, and C. So like you have A, B, and C numbers. For the first iteration, in this definition, you have 1 and 2 as A, B, and C, as A and B. And then C is your sum, which is going to be 3. And so then if you go to the next iteration, 2 and 3 have become your A and B.
Right.
And the sum is 5, so that becomes your C.
Yep.
So, you sort of have this sliding effect where B and C become A and B. So if you just recur with that in mind, essentially, then you can build a solution to this. So I'll just start from what I've done before, and I know there's problems with it, but
Okay, that's fine.
I'll just say I'm going to define a Fibonacci program that takes 3 parameters. Oh, no. A and B are all it needs. No. It doesn't take a C. It just takes an A and B. But it needs to have a number of terms that it's going to be finding.
Mm-hmm.
So then if the first thing that I do is to say that, oh no, but don't I have to have something to collect it all, don't I? So maybe it'd be better if I did it this way. I'm sure Proctor's going to say, why didn't you use reduce?
That's right.
Okay, so I'll say result as one of my things. So now what I want to achieve is I want to add A and B. No, that's not what I want to do. I want to join to the result of adding A and B, but I don't really want to do it that way because that's not recursive. What I need to do is I need to take a step into the recursion and call Fibo, and that's going to be on B and C, but I haven't defined what C is. What am I doing? Oh, no. It goes like this. Okay, now I'm thinking. Okay, the sum of B and a call to Fibo. I think I'm getting a little bit lost.
Okay.
Fibo of B and C.
Here, while you do that, I'm gonna write it on my side, and then we can do some comparison.
Sure. Okay. So the first thing I want to do is I want to decide. So the Fibonacci says if I've hit the N, if N is equal to the length of my result. What's the function, John? Is it len or length? I can never remember in Clojure.
That's a good question. I think it's
Or size or...
Hold on. I don't think it's either. So you could probably count though, right?
Oh yeah, count. That's right.
Yeah.
There we go. Thank you.
Mm-hmm.
So count of result. Then I just return result. But otherwise, I want to add to the result of calling Fibo on B and A plus B. Too few arguments to if. Oh. Okay. This needs that closed. Oops. I'll take it off from there. Okay. So Fibo 3.
So a suggestion from the audience is to, it might be easier to start with a base case and then utilize recursion for the next case.
Okay. I think I might have already done that. If they were doing what I'm thinking of, because I've made this anchor case of if n is equal to the size of the result vector. But I don't know how current that suggestion was. Maybe I'm missing something.
Yeah, it was about 3 minutes ago.
Okay, yeah. See, 3 minutes ago I was lost. Now I'm found, so.
Okay.
Yeah, so now the result is joined by dun. Fibonacci. Oh, I know what I did. That was really dumb. So I'm just retyping what I did the first time because I noticed what I did wrong. So the anchor case, I just want to return the result, and otherwise I want to return the result joined by the result of calling Fibo with, oh, but you know what? I've designed this function signature all wrong because I don't want to actually pass. Well, I guess I could. Do that. I was going to say I didn't want to pass the 1 minus the n being the number of terms that I want, the number of Fibonacci numbers. But I could do that. It's not wrong to do that. So I guess I'll just say decrement n and then pass result here. Is that going to duplicate my result? Cons result and passing result. Don't think so. It's been a little bit since I wrote something this recursive, though, so
Sure.
I'm just trying to hold on to my reasoning. So let's say that I want the first 5 terms of the Fibonacci sequence. Oh, and I have just given myself a big pile of brackets. What am I doing wrong? So I should confess, last time I did this, I had just recently watched the lecture from Structure and Interpretation of Computer Programs where they did this.
Yeah. All right. Well,
so it was very top of mind when I did it last.
Sure. Well, I think I might be able to help you out a little bit. So
yeah, I need
so
some help.
over in the chat, if you head back over to yeah, over there. Yeah, I put in something that might be able to help you out.
Okay. Let's see my salvation here. Invalid token usage.
Is that?
Oh, it looks like I
close friends.
No, I.
Oh no! You kept
it's
the whole
because
message.
I pasted too much. Too much pasting.
There you go. All right.
Okay.
So now, but yes, in that message also showed some usage. So you can map fib over a range, right? So
map fib over a range. Okay. I'm really curious to see this now because this is like new to me.
Yeah,
okay, so I'm going to map range.
Like 1 to 10.
Okay, 10. Yeah, oh, sure. No, 1 didn't, so I start with 1. Right.
Okay. Yeah. Yep.
Okay, the functional mindset is starting to function.
So yeah, take a look at this and let me know how it reads.
Okay, so let's see what I've got. So I've got if it's either the x equals 1 or x equals 0, then I have 1. Otherwise, I want to sum a call to fib minus 1, minus 2. So I want to format this again, so I'm going to retype it.
Okay.
So sorry about the time delay. I'm just going to give myself a little favor of seeing the lines in the order that I like to see them in. So
Absolutely.
Or x1 equals x0. And you close that there.
Then it's 1.
If or then it's 1. Otherwise, it's the sum of a call to fib with the decrement of x and minus x2. So I think I tried to get too complex because my mind did not go the same route and I just really flubbed it. But I like this way a lot. So I see now that I've read it, I see that you've done, if it's either x equals 1 or x equals 2, then it's simply 1. And otherwise, then you just make a recursive call. So you sort of walk backwards down the range of numbers. Okay.
Yes. Right. So now we've got our list of Fibonacci numbers, right? So we need to get that sequence of values do not exceed 4 million, and then sum.
So the values can't exceed 4 million. So that's the interesting thing, because we're talking about values. We're not talking about the 4 millionth number. We're talking about the value. So it's a little bit of a challenge because you want to do this in some way that doesn't compute all the Fibonacci's before it throws out all the ones greater than 4 million.
Yeah, so you need something like a lazy sequence.
Okay. So laziness is a new topic for me in a sense, because it's always happened without me wanting it. I've used laziness before, but only when it kept me from seeing the result I expected to see. I just So essentially I've used it by accident.
Okay.
So what can I do to use a lazy sequence?
Yes. Yeah, here, let me put something in the chat.
I hope that somebody in the audience is benefiting from all the stupid questions I'm asking.
No, this is great. Yes, absolutely. Right? So here, let's do this. 1 second.
Sequence lazy. Okay, let me pull this over into my... So this time I'll just type it from the start.
Okay.
Sequence lazy. So that means I'm going to be mapping the first function. Oh, okay. I see doubly nested brackets, and I know that something is getting
It's
very...
being destructured. So that's what's happening there.
So I've got my function. I'm building a new vector, A, B, oops. And now I'm interesting. Okay, and I'm going to I think I might have made a mistake somewhere, because I don't have as many parentheses at the end as you do. So let's just proofread this. Map first iterate function A, B, B. Ah, here it is. Fib seek lazy. Okay, so what I see is that we're mapping the function first over the result of iterating over... Actually, I'm not familiar with iterate. if I'm being honest. So I'm assuming that it takes this sequence 1, 1, and that it's going to then proceed to apply this function to it.
Yeah, so recall in your Rebel read line, you can type in the name of the function and do Control XD, and you'll get some documentation.
Control XD. Okay. Returns a lazy sequence of x, f of x. Oh. Oh my word. Okay, well, that's perfect. I'm just applying the function iteratively. Now, what the function does is it takes b and the sum of a of b, and then destructures that out again. So b becomes a, the sum becomes b, and then does that again. And I'm assuming it does that lazily. Oh, it does say that. Okay. And you're only taking the first of each. I guess that's my question is why first?
Yeah, so lazy is only going to give you the very next answer. But you know, you could ask that for infinity if you needed to. So take a look in the chat again, right? And we'll see the solution to the problem.
Reduce plus filter. So I'm taking out all the ones that are even. I'm taking all the ones that I find up until the point that it's greater than 4 million. 1, 2, 3, 1, 2, 3. And that is done on the result of calling fib seek lazy. Now I close my parentheses. Okay, so I see a numbered result, but more importantly, I see reduce plus. So I'm summing up the result of filtering all the evens out of, I call it the take while, which is going to give me a sequence of all the Fibonacci numbers that are less than 4 million that are generated by, I call it the fib-seek lazy. Fib-seek lazy iteratively generates a list of Fibonacci numbers.
Or functions that generate Fibonacci numbers.
Oh, I see. So yeah, that's what I'd like to see. Let me, just as an experiment, do this out of its context. I want to see what it does when I say iterate function a, b, b, and the sum of a and b. And I want to iterate that function on the vector 1, 1. So what does that tell me then? Integer overflow. So I didn't do the first part of this, which was to map first over it. I feel like there's something that I can learn from this that's like just barely starting. You know, the cookie is starting to bake here, but I'm not quite on your level with this solution, John. This was really quite a solution, I gotta say.
Yeah. Well, so just in transparency, right? So I pulled this so that way we had time to move on to the next section as well. So
okay.
I'll put the reference into the chat for anyone who wants to go further on this problem. Right, there's a blog post to discuss this in more detail, so I'll just throw that up there as well.
Well, it's always good to feel a little defeated, you know. If you're feeling defeated every once in a while, but it's still okay, and people are still like telling you good try, then you know not only that you're challenging yourself, but that you've challenged yourself among people that also value how hard you're trying. So
Yeah.
I feel very supported right now.
Absolutely. Right, right. And that's part of why the meetup exists, right? We
Right.
want to attract more people to thinking functionally, and we want to help them grow in that, so that way they can develop those simpler systems. Um, all right. Well, let's wrap up by talking about today in closure. So if you want, I will share my screen again. Okay. Right, and let's talk about over here. So todayinclosure.com, it's kind of like Hacker News, but for closure, all things closure. And so the way that they do that is they aggregate a collection of different different sources, from Closureverse to, in some cases, Hacker News. I think it's actually discussed in the about a little bit. Yeah, so Reddit, Closureverse, Hacker News, Stack Overflow, and Maven for new closure releases. Right, the source code for this is also listed. So todayinclosure.com, right? So I wanted to just go over some of these things. One is you'll see a collection of links to the advent of code that is going on right now. And so there are some streams of people completing some of the advent of code problems using Clojure, right? So this is a great opportunity for you to learn and watch of some of those solutions getting solved. And so I think that's great. But also, I noticed that there's this Reddit request on Babashka running on a serverless platform. So if you're not familiar with Babashka, right? So Borkdude has created Babashka, and it's pretty cool. So here, I'll pull it up real quick. Here we go. So it's called a closure babushka for the gray areas of Bash, right? So life's too short to remember how to write Bash code. I feel liberated, right? So this allows you to use the closure syntax, right? The way that you tend to think about your closure code, but in the context of Bash, right? So you've got like a Bash command, you pipe it to Babashka, right, and then perform some filtering or whatever it is that you want to do on the data, and then deal with it as you would. So you don't have to worry about bringing in the Java runtime, right? It'll right. So right here, no JVM needed. Super cool, right? So, but going back to this Reddit thread. So people have started to post links to some implementations of Babashka running in AWS Lambda. So you might be wondering, okay, well, why is this interesting? Well, what I've seen so far is that some of these implementations, they actually allow you to use the AWS editor, right? The inline code editor for AWS Lambda, and so they allow you to write closure in there just as part of the normal experience. And then it knows how to transform the output into something that Lambda can serve up to others. So I'm thinking, like, in a future meetup, perhaps we explore that a little bit further and show you how to write your own Lambda functions using just closure. But anyway,
Yeah, that would be exciting.
yeah, it'll be super cool. So yeah, I just wanted to point out today in closure, in case you hadn't, heard of that before, and I'll put that link in the chat as well. So um, so I'll do that, and then do you have any last remarks? This is the last meetup for the year. It's hard to believe, but
Yeah,
my, what a year it's been.
it has. It really has. We've only missed a few. I think we may have only missed 1 month, but every month that we met, I think was just, it marked a new milestone in like my closure learning, as well as everyone else's. But on a personal note, that's what it meant to me. And I'm just grateful for you starting this meetup, John. And I'm grateful for the expertise that we have here among yourself and among Mike and Proctor and some of the others that have been attending. And it's just really exciting to, that it's local, that here in South Lake, Dallas, Denton, in the area. And, now as with a reach as broad as Brazil and everybody else who wants to join the meetup, that we can share what we're excited about. So
Yeah.
it's a really nice way to stay engaged with closure, which is what's saved my sanity while battling. What a challenge it is to join the enterprise software world and have to slow your roll so much. It's just disheartening. It's so disheartening. So
Yeah.
that's what this meetup has meant to me, and I just have really enjoyed it.
Yeah, absolutely. Yeah. And I've loved seeing this community grow, and the type of speakers that we've had. I mean, I've loved these topics.
Yeah, I'd say our speaker list, it doesn't quite fit when you think about our attendance. Like we have, at most around 40 people, and now fewer, I think. But we've had speakers as prestigious as Gene Kim and Mike Nygaard. So what can you say? I guess we're just lucky, and I think people's love for closure drives them to share it, even though it's not a prestigious audience. But
Yeah. Yeah. Well,
yeah,
I mean, it's kind of reflective of the closure community, right? I mean, we're kind of tight knit. There's not necessarily a whole lot of people at the moment, yet there's some pretty amazing stuff that's done within this community, right? So, who knows? Maybe in the future, when COVID is no longer, right? Then maybe we'll get participating in the conference role. So we'll see what happens. So
definitely.
yeah. Anyway, so thanks a lot for speaking tonight and for showing the project you were working on. And for everyone watching online, we'll hope to announce some upcoming topics pretty soon, and then we'll hope to see you soon in the new year. So thanks for joining us, everyone. We'll see you in January.
Okay. See you next year, John.
All right. See you next year.